Carrington, here's number 72. The first thing you have to do here to find the inverse, obviously, is switch x and y. You can see I've already done that. Now, what makes this problem a little more challenging is you can see that both in the numerator and the denominator on the right-hand side, you have expressions that contain y, and that's what we're trying to isolate. The first thing you have to do is you have to get that y that's in the denominator, that 2y plus 5. You got to get that out of there. And since it's division there, we're going to get it out of there by multiplying by the entire binomial, 2y plus 5. I'm going to multiply by that on both sides. And so, on the right side, it's no big deal. That just cancels out. On the left, I have this. I have x times parenthesis 2y plus 5. And that's now equal to 5y minus 3. Now again, the issue you have here is that you have several terms or two terms that contain y, and we have to get them on the same side of the equal sign, and right now they're on opposite sides. The first thing I'm going to do, though, is I'm going to distribute this x through the parentheses, and I think you'll see why I have to do that in a moment. But you're going to have 2xy plus 5y is now equal to 5y, that 2xy plus 5x is equal to 5y minus 3. Now again, I have two y terms. I have a 2xy term and I have a 5y term. I have to get those on the same side because I got to get those y's together eventually. So I'm going to subtract 5y on both sides. I'm going to have 2xy minus 5y plus 5x is equal to negative 3. Now again, I'm trying to isolate y, so the term that doesn't have a y has to be moved to the other side. So I'm going to subtract 5x on both sides now. And so when I do that, now I've got my 2xy term minus my 5y term, and that's now equal to negative 5x minus 3. Now, the issue we have is we cannot combine the 2xy and the minus 5y, but we can factor out the y because it's a common factor in each of those terms. So I can pull the y out. So I have y parenthesis 2x minus 5 is now equal to negative 5x minus 3. And now I want to get y alone. Remember, that was my goal all along. Because this is multiplication between the y and the binomial 2x minus 5, I can just divide by 2x minus 5 on both sides. So I'm going to do that. And I can cancel then that 2x minus 5. And now I actually have succeeded in getting y alone. So I now can say that y is equal to negative 5x minus 3. And that's being divided by 2x minus 5. I'm going to replace y with inverse function notation because that's really what I've just found. So I'm going to write instead of y, f negative 1 of x is equal to negative 5x minus 3. And that's being divided by 2x minus 5. So this would be your inverse function. Now, if you have to do, I'm probably going to have to go onto a clean page here. If you have to do finding or doing the composition of the two to prove that they're inverses, we can look at that. As far as whether or not this is a function, I'm pretty sure that it is because I looked at the picture earlier, but you may want to graph that in Desmos just so you can see what that looks like. But let me, on the next page, we'll talk about checking to see that that's actually an inverse or confirming that. One other thing, they may, I know you can't see this answer in the back of the book because it's even, but one thing that they tend to do, when the top terms, both of them have a negative sign, sometimes they'll factor the negative sign out and then just write this as 5x plus 3 on the top over 2x minus 5 on the bottom. They're just pulling that minus sign out in front. It is the same thing. So Carrington, to check to see that they're actually inverses, I started by taking the inverse function and plugging it into the original function. It's a little bit messy because you're plugging a fraction into a fraction, So what I did there was I took my inverse rule, as you can see, and I plugged it in, so that fraction for the inverse rule has to get multiplied by 5, and then I have to subtract 3. And then on the bottom, that same fraction, the inverse rule has to get multiplied by 2, and then I'm going to add 5. I have to get rid of those fractions within a fraction. And the way that you do that is you multiply by the denominators. So what I did there, well, first of all, let me just say this. The first thing I did was I distributed the 5 to the numerator on the top, and I distributed the 2 to the numerator on the bottom, because remember, this is 5 over 1 and 2 over 1. And so then you get the expression that you see just below that. Now I have to be able to somehow combine like terms, and I've got fractions and whole numbers. The easiest thing to do there is literally the denominator, that 2x minus 5, because it's the same top and bottom, I'm going to multiply top and bottom by 2x minus 5. So if I multiply by 2x minus 5 on the top, the fraction, but I also have to do that to that number 3, because those are two separate terms and they have to be treated the same. And then I'm going to do the same thing on the bottom. This fraction is going to get multiplied by 2x minus 5, and the 5 also has to get multiplied by 2x minus 5. And so then top and bottom, those fractions are going to cancel out. And so if you follow my arrow, you can see that you end up with negative 25x minus 5. And then I have a negative 3 now times parenthesis 2x minus 5. And the same thing on the bottom, the fraction cancels, so I just have that numerator, negative 10x minus 6. But then I have to add to that 5 times the 2x minus 5. I actually have to do that multiplication because the 3 and the 5 didn't have that 2x minus 5 as a denominator that would cancel. So now I'm just going to distribute to get rid of the parentheses, and then I just combined like terms. So the negative 25x and the negative 6x on the top gives me negative 31x on the top. The 15s cancel. And then on the bottom, the negative 10x and the positive 10x cancel, and negative 6 minus 25 more is negative 31. So the negative 31 over x over negative 31, the negative 31s cancel, and you can see I just get x there. Now you will do the exact same thing to find or to confirm it the other way around. I'm not going to walk through it on this video because this video is getting really long and YouTube limits me. But I don't know if you feel like you can do that on your own. Give it a try. Just the second time you do it, it's going to be in the reverse, obviously. So you're going to take the original function and plug it into the inverse. So you're going to have your inverse function on the outside and your original function on the inside for the notation. And then that just means we're going to take that fraction from the original function and plug it in. So we'll have negative 5, and then we'll have our fraction 5x minus 3 over 2x plus 5. And then we have to subtract 3 from that. And then on the bottom, you're going to have 2 times that same fraction, 5x minus 3 over 2x plus 5. And then that's going to be minus 5. And then from there, it's just algebra. Distribute the negative 5 through on the top and distribute the 2 through on the bottom. And then after that, you're going to multiply by the 2x plus 5, but you really won't have to deal with it in the fractions. It'll just cancel out. It's going to be the 3 and the negative 5 that are really, it's going to matter that you multiply those by 2x plus 5. And then the algebra from there should work out. So if you need more help with this, we can talk on Wednesday, or even, I guess, tomorrow during e-learning. If you want, you could shoot me an email, and I can finish this up for you. Have a good night.